In order to graph polynomials, we first need to factor the polynomial. Once we've factored the polynomial, we'll know the zeros, and we can find all the points around the zeros. So if we want to graph this polynomial, step 1, factor this polynomial. To factor this polynomial, we need to find a factor that divides this polynomial evenly. To figure out that number, we're going to use our calculator, and we're going to find a 0 of the function. It looks like we have a 0 at 2, and at 4, and at 8. So let's try those points. If I type in 2, well, 2 is not exactly a 0. If I scroll close to that number, I can get close to the 0, but I can't get exactly 0. It looks like it's about 1.7. If I try 4, 4 is a 0. And if I try 8, 8 isn't quite a 0. It's close, but it looks like it's about 8.3 maybe, but it's not exactly 8. So the only integer 0 that I have is 4. So I'm going to synthetically divide by 4. Drop down the 1, multiply, add, multiply 4 times negative 14, negative 56, 110 plus negative 56, four times 54, add, multiply. Add. Well, this is good. I do get a remainder of 0. I synthetically divided by 4. 4 is a 0 of this function, which means that x minus 4 is a factor. Now I want to graph x cubed minus 14x plus 14x squared plus 54x minus 56. I need to find a 0 of this function. Looks like I have one at 2, at 4, and 8. Let's try those. 2 doesn't work. If I try to trace closer to it, there's that pesky 1.7. It's not exactly 1.7, but it's about 1.7. 4. Yep, 4 is a 0. And if I try 8, 8's not quite right either. It looks like it's about 8.3 still. But it's not exactly 8.3. It's close. So I'm going to have to use 4. 4 is the only integer 0 that I have. So I'm going to synthetically divide by 4. Drop down the 1, multiply, add, multiply, add, 4 times 14, add. Good, I got 0 for a remainder. So 4 is a 0 of this function, which means that x minus 4 is a factor. And I'm left with x squared minus 10x plus 14. So I'm going to graph this function. Looks like it crosses at 2, but it's not exactly 2. It's close to 2, like 1.7, but it's not exactly 1.7. It looks like it should cross at 8, but it's not exactly 8. It looks like it's about 8.3. So how do I figure out those two last zeros? Well, if you look, I have a quadratic, and to find the zeros in a quadratic, I can always use the quadratic formula. So I factored from a quartic down to a cubic, from a cubic down to a quadratic. Once I hit a quadratic, I'm going to use the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. A negative negative 10 is positive 10. Negative 10 squared is positive 100 minus 4 times 14 is 56 all over 2. So I really have 10 plus or minus the square root of 44, 100 minus 56, over 2. Well, I can simplify this square root of 44. 44 is divisible by 4. 4 is a perfect square. So I'm going to rewrite the square root of 44 as 2 square roots of 11, all over 2. Which, when I distribute this divided by 2 to each term, I'm left with x equals 5 plus the square root of 11, or x equals 5 minus the square root of 11. Well, let's look at this. 5 plus the square root of 11. Hey, look at that. It's about 8.3. And if I try 5 minus the square root of 11, I get about 1.7. So my last two zeros are 5 plus the square root of 11, which is about 8.3, and 5 minus the square root of 11, which is about 1.7. If I look back at my graph, if I type in 5 plus the square root of 11, I should get an exact 0. And if I type in 5 minus the square root of 11, I should get an exact 0. These are my exact answers. These are my approximate answers. It's about 1.7 and about 8.3. So to rewrite this as a function that's in factored form, my factors are x minus 4 and x minus 4. Well, x minus 4 and x minus 4 I'm going to rewrite as x minus 4 squared. And then I'm going to have x minus this 0. So I'm going to have x minus 5 plus the square root of 11. Notice how 5 plus the square root of 11 has to be in parentheses inside of these parentheses, because I'm subtracting this whole 0. And my last my last factor is going to be x minus 5 minus the square root of 11. My zeros are going to be at 4 and 4 and 1.7 and 8.3. So to set up my table, I'm going to find the points around my zeros. So the smallest 0 I have is 1.7. So I'm going to start my table at 1. And the biggest 0 I have is 8.3. So I'm going to make my table go all the way through 9. Well, since I'm starting with 1 and ending with 9, I can hit every integer along the way. Now I'm going to go back to my calculator and I'm going to plug x in for all of these values into my original function. So I'm going to go back to y equals, and I'm going to use this graphing utility and the trace function to find all of these values. I could just plug 1 in, and then plug 2 in, and then plug 3 in, but I'm going to make the calculator do a lot of the tough work for me. Now if I hit graph, and then I hit the trace button, I can type in all of these values. I can type in 1, and my answer is 45. I can type in 2 and get 8. And I can type in 3 and I can get -7. And 4, hey, I get 0. I knew that. 4 was a 0. 5, 6, 7, 8, and 9. So I know my zeros. I'm going to put a point at those zeros. So I have a 0 at about 1.7. I have a 0 at 1, 2, 3, 4. And I have a 0 at 8.3. Now I left the y-axis blank. I can make the y-axis whatever I need it to be. My highest value is 125, and my lowest value is -63. So I don't want to count by ones. I'm going to try just counting by tens. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120. And I'm going to count by tens in the negative direction also. 10, 20, 30, 40, 50, 60, 70. I just need to make sure that I go far enough to bracket my range. So when x was 1, my output was 45. 2, I get 8. I get -7. There's something that I did wrong here. I can't have these numbers work this way. And when I look back, when x is 2, y is actually -8. So I need to change this 8 to a -8, which means that this value right here should be down here. That makes a little more sense. When x is 4, y is 0. 5, I get -10. 6, -40. 7, -63. 8, -32. 9, 125. So how do I connect all of these dots together? Well, if you remember, x to the 4th is a quartic graph. It's either going to look like this or like this. In this case, I'm going to start right here and connect down. Then I'm going to go up and hit this point, come back down, and hit these values along the way. So if you look at this graph, it's actually this graph right here. Now a few things I want to point out about this graph. Here's a 0, here's a 0. This point right here, since the graph goes up and touches and then goes back down, is known as a repeated solution. The reason it's a repeated solution is I have x minus 4 twice. So I still get 4 zeros, I just get 4 twice. X minus 4 squared. So I still have 1, 2, 3, 4 zeros. And they're all real. It's just that some of them are irrational. And some of them are integers. They're rational. Our last example, we're given the graph and we need to write the equation of the polynomial. To do that, we need to find the zeros of our graph. So I have a 0 here, and here, and here. So the zeros for this graph are at -1, 2, 3, at 0, and at 2. So to write the function, if -3 is a 0, x plus 3 is a 0, x minus 0, and x minus 2. Now I need to multiply these together. But before I do that, I'm going to simplify x minus 0 down to just x. Now I'm going to distribute. X times x is x squared plus 3 times x. And I need to take that answer times x minus 2. X squared times x is x cubed minus 2x squared plus 3x squared minus 6x. Finally, simplify my like terms. I can always check my answer by graphing this function. X raised to the 3rd power plus x squared minus 6x. This graph looks just like this graph. So So to graph a function, first factor it, then find the points around the zeros. If you have a repeated solution, your graph will just go up and touch the x-axis. If you have irrational zeros, your graph will cross the x-axis at decimal values. If you have the graph, to write the function, find the zeros, then figure out the factor for each zero and multiply.